Hello everyone, this is Manish from Skillable India. In today's session, we are going to learn the very important topic, which is the rule number one. Okay, so we all know that games cannot be played without rules. Okay, so it is true also into GD&T. Okay, so that's why we are going to understand the two rules. First of all, in this particular session, we are going to understand the rule number one. Actually, this rule number one is a very big topic, so I have converted this rule number one into two parts. Okay, so into the first part, so I'm going to tell you a very important rule which is into the geometric dimensioning and tolerancing, which is called rule number one. Okay, so in this rule one, it is the also called at perfect form at MMC. Okay, so one by one, I will in the further this session I will tell you that why it is called perfect form at MMC, why it is called envelope principle. Okay, envelope principle. Okay, and again why it is called individual feature of size rule. Okay, so this rule number one has three names. First of all, if we move forward, okay, so I will write it down three names over here. Okay, so this rule is called perfect form at MMC. Perfect form. Form is also called the shape. Okay, shape. Do not get confused. So perfect form at MMC. Secondly, this rule is called the envelope principle. Thirdly, this is called the individual feature of size rule. Individual feature of size rule. Okay. So one by one, we are going to discuss that why we are understanding this. So first of all, if we understand with the help of definition, so rule number one of the geometric dimensioning and tolerancing states that the form of a regular feature of size. Okay. So we are talking over here is about the regular feature of size. Okay. I have already told you about the regular feature of size, irregular feature of size. Irregular feature of size is of two type A, type B. Okay. So we have already discussed these things, but briefly I am going to tell you. Regular feature of size is the feature of size which we can measure with the help of vernier caliper. Okay. So it states that the form of a regular feature of size is controlled by its limit of size. Okay, so limit of size over here, you can see over here is dia 10 plus minus 12. Okay, so limit of size is the dimension. Okay, so limit of size or otherwise known as the size tolerance. Okay, so this plus minus 2 or 10 plus minus 2 is called the size tolerance. Okay, can be seen in many forms. A few of them are asymmetric, unilateral and bilateral. Okay, it is sometimes also known as the Taylor's principle. Okay, so this size tolerance can be symmetric, this can be unilateral, this can be bilateral. Okay, it is sometimes also known as the Taylor's principle. Okay, so this is all about the rule number one definition. Okay, so the second one is the actual surface of a regular feature cannot extend beyond the envelope prescribed by the feature of size in the perfect form at MMC. Okay, so this particular I will tell you with the help of example that why the actual surface is the this surface. This surface cannot extend. Okay, cannot extend beyond the envelope prescribed. Envelope, we are going to tell you, I'm going to tell you what is envelope over here. Okay, so why we are learning this, the rule one. Okay, we need to ensure that the shaft should enter into the hole. Okay, so the part shaft or the pin is going to be entered into the hole. So what that's why we are understanding this rule one in detailed manner. Okay, so envelope is basically the maximum material condition of the shaft. In this case, you can see we are taking an example of shaft. Okay, so we are taking an example of a shaft. So the maximum material condition over size of this size. Okay, so MMC and LMC. So MMC of this shaft is 12 dia 12 mm and LMC is dia 8 mm. Okay, so with this example, I will tell you that how this cannot extend beyond the prescribed feature in the perfect format MMC. This means that if the feature measures at MMC, let's say if we are measuring this pipe part and manufacture this part at MMC, let's say this shaft is manufactured at dia 12 mm. Okay, so that it must be perfect in shape. Okay, so this shape should be perfect. Okay, if this is not perfect at MMC, at maximum material condition, then it will not enter into the envelope. Okay. So the perfect form of the feature must be perfect. Okay. Which is into the real world. If we talk about with the manufacturing process, it is very, very difficult or it is almost impossible to manufacture the exact shape. Okay. Or at the perfect format MMC. Let's say in this case it's 12 mm. So we want some deviation. That's why we provide the tolerances to the part. Okay. Because if we are strict to the size of the part and the form, and we do not want any form error in the part. Okay. So the cost of the part will be very, very high. Okay. So to reduce the cost of the part also in the manufacturing of the part, we provide the tolerances. Okay. We give some tolerance to that part that it should get assembled with the mating part. Okay. So let's move further. So this is the drawing. Let's say with the help of examples, we will understand this. First of all, this is the drawing we give to the manufacturer. This drawing of the shaft we have provided to the manufacturer. Okay. So what are the conditions that manufacturer will manufacture the part? Okay. So condition number one. So this is the condition number one. This is the condition number two. This is the condition number three. And this is the condition number four. Any of these conditions, this part can be manufactured, and there are multiple conditions also. We are taking only four conditions over here. Okay. The manufacturer can manufacture the part. A person who is a machinist will manufacture this part in many ways. Okay. So these four conditions I am taking here. So one by one we will understand that what are the different conditions in this. Okay. So to understand this rule better, we will understand with the envelope. Okay. So we have a regular feature of size with the limit of size. Okay. So you can see in this example only, we have a regular feature of size with the limit of size. So dia 10 plus minus 2 mm is the regular feature of size with the limit of size. Okay. So after manufacturing, let's say this is the condition number one. This is the case one. Okay. This is the case one of this part. So I have already told you about the limit of size. Okay. So the rule tells that when only limit of size is given onto the drawing. Okay. So this rule tells that when only the limit of size is given onto the drawing, the limit of size not only controls the size of the part. So this limit of size not only controls the size of the part, but also controls the geometric form or shape of the part of this part at some extent. Okay. Of this part at some extent. Okay. So this limit of size is controlling size of the part and geometric form of this part at some extent. So let's go in detail. So after manufacturing, I have already told you. So after manufacturing this part, we can manufacture this part in many ways. Okay. So this part should enter into the we have to fulfill some conditions. Okay. So there are some requirements that needs to be fulfilled to obey rule number one. Okay. First condition, first requirement is that if we measure this part at this point, okay. So wherever we measure this part, if we measure this part, the actual local size. So we are talking about actual local size. Okay. So the actual local size should not be more than 12 mm. Okay. And not more than 12 mm and not less than 8 mm. Okay. So in this case, the actual local size you can see is 10 mm. Okay. So here it is 10 mm. Here it is 10 mm. All the way it is 10 mm. Okay. So the actual local size within the size tolerance. Okay. So from 8 mm to 12 mm, this size should be there. Okay. Because this is the MMC and this is the LMC of this shaft. Okay. So the actual local size should not less than 8 mm and more than 12 mm. Okay. Second condition is, so this is the first condition. Second condition is this part should enter into the envelope. Okay. So this is the envelope. This part should enter into the envelope of maximum material condition. Okay. So the maximum material condition of the shaft is 12 mm. Okay. So the maximum material condition of the shaft is 12 mm. So we have created an envelope of 12 mm. Okay. So this rule is saying, this second condition, that the part should enter into the envelope of maximum material condition. So this part is entering into the envelope, okay, because this size is 10 mm and this variation we are having over here is 2 mm, okay. So that's why this part is entering into the envelope, okay. So this part should enter into the envelope of maximum material condition, which is dia 12 mm in this case, okay. So this part is entering into the envelope, means this part is fulfilling the second condition also, okay. So means this part is obeying rule number 1. This part is obeying rule 1. Now we will see the second example. So in this example also you can see that the actual local size, first condition is actual local size is within the size tolerance. So maximum we have 12 and the minimum we have 10 mm. So it is varying within the range. Okay. So from 8 to 10, from least material to maximum material condition, it is varying. Okay. So this condition fulfills the first condition, that the actual local size is within the limits. Okay. The second part is it should enter into the envelope. So this part is also entering into the envelope. So the second condition is also fulfilled. Okay. So you can see that this part is also, this is the second manufactured part. Okay. So this part is also obeying rule number 1. Now we will see the third example. Okay. In this first condition is actual local size is within the size tolerance. So let's say this is 8 mm. Here it is 10 mm. Here it is 12 mm. And again here it is 8 mm. Okay. So means the actual local size is within the limit of size. First of all, first condition is satisfied. The second condition it should enter into the envelope. This part is entering into the envelope. Okay. Because the size is 12 mm over here. And this part maximum size is 12 mm over here. Okay. Maximum we have 12 mm dia. So this part is entering into the envelope. So this obeys rule number 1. Now, this is the fourth example, fourth condition. Okay. So first of all, the actual local size of the part is within the size tolerance, which is 10 mm all over this part. So the rule number, condition 1 is satisfied. Condition 2 is it is entering into the envelope. Yes, it is entering into the envelope. Okay. So the second condition is also satisfied. Okay. So this part is also obeys rule number 1. Okay. Now, in this example, after manufacturing the part, the actual local size of this part is 12 mm. Okay, let's say here dia 12, here it is dia 12, here it is dia 12. Okay, so the first condition is satisfied. The actual local size is within the limit of size. Okay, but it is not entering into the envelope because it is having the bow shape like this shape. Okay, so in this it is not entering into the envelope. So it is not obeying rule number 1. So this part is not obeying rule 1. Okay, because it is not entering into the envelope. The maximum size we have over here is 12 mm, but it is having a bow shape and the actual local size is of 12 mm, means this size, the size over here from here is more than 12 mm. Okay, so this size is more than 12 mm, so it is not able to enter into the envelope. Okay, so in this case it is not entering into the envelope, so this doesn't obey rule number 1. Okay, now why this rule number 1 is called the perfect form at MMC. Okay, now we will understand this thing in a very detailed manner. Okay, why it is called perfect form at MMC. So let's say this part is produced at a local size of 12 mm. Okay, so the actual local size at every point is dia 12 mm. Okay, if this part needs to get into the envelope, okay, if this part needs to go into this envelope, it should have the perfect form. So in this case, first condition is satisfied. Over here you can see that the actual local size is between the size tolerance, which is dia 12. So the first condition is satisfied. Okay, it is well within the limit of size and enters into the maximum material condition envelope. Okay, so now it is entering into the envelope and it is entered into the envelope. This part is entered into the envelope. Now, so this part obeys rule 1. Okay, so this is also condition satisfied. So this obeys rule 1. Okay, but the thing is perfect form. If the part is manufactured at maximum material condition, the form of this part, the shape of this part should be perfect. Okay, the form error is not acceptable. Form error at MMC is not acceptable for obeying rule 1. Okay, so if the form at MMC is perfect, so it obeys rule 1. Okay, so that's why we say that whenever the part is manufactured at maximum material condition, so it should have the perfect form, which is impossible to manufacture, or say it will increase the cost at very high if we need to assemble this part. Okay, so that's why we call this part at perfect form at MMC. Okay, so this is why we say perfect format MMC. Now, one by one, I will tell you what are the requirements. Okay. So in detail, we will understand to fulfill the requirements of rule number 1. One by one, we will understand. So rule number 1 is a dimensioning rule that ensures that the individual regular feature of size will assemble with one another. Okay. So why we are learning this rule number 1? Because we need to assemble the mating parts, the hole and the shaft with one another. Okay. So what needs to be taken as a mind, as a designer, as a design engineer, what are the things you have to keep in your mind that are important to obey the rule number 1? Okay. When rule number 1 applies to a regular feature of size, okay, which is the very important thing. Rule number 1 is only applied to a regular feature of size. It establishes an overall boundary, okay, or the envelope. So whenever it is manufactured at regular feature of size, so this forms the boundary or the envelope or for a regular feature of size that is equal to its MMC. So in this case, 10 plus minus 2. So the MMC, maximum material condition of the shaft, is dia 12 and the least material condition is dia 8. I have taken very wide tolerances just to understand you clear. Okay. So maximum material condition, let's say, so this envelope will be at the maximum material condition. Okay. So this envelope will be the maximum material condition. Now, rule number 1 applies to an external regular feature of size. External means we are talking about shaft. External regular feature of size. The maximum material condition maximum boundary or the envelope of a regular feature of size is equal to its largest size. Largest size for the shaft is 12 mm. Okay. So we are for the example of shaft we are taking. So the maximum material condition of the shaft is 12 mm over here. Okay. Sorry. I will make it over here. Okay. So if we are talking about shaft, okay. So dia 10 plus minus 2. This is the limit of size we are given here. So the maximum material condition will be dia 12 mm. Okay. So it is saying that to its largest size, limit size. Okay. MMC. So in this largest is to dia 12. LMC over here is dia 8 mm. So we are taking 12 mm the maximum material condition for this envelope. Okay. When rule number applies to an internal regular feature of size, here we are talking about hole. Okay. So whenever we are talking about hole, so we will make one drawing of hole. Okay. Let's say this is having dia 10 plus minus 2 in this case also. Okay. So what will be the maximum material condition of hole is dia 8 mm and least material condition of the hole will be 12 mm. It is opposite to the shaft. Okay. Because in this case, this part is having maximum material condition at MMC. Okay. When the hole is smaller, the part is having maximum material. When the shaft is bigger, it is having the maximum material. Okay. So maximum material condition is when the part is having maximum material, more amount of material. When the part is having less amount of material, it is called the least material condition. Okay. If the shaft is smaller in its dia, means it is having less material. So it is the least material condition. When the hole is bigger, means the part is having less material. Okay. So it is the least material condition. Okay. So basically it is saying that MMC, whenever rule number 1 applies to an internal feature of size, which is hole, the minimum boundary or the envelope of the regular feature of size is equal to its smallest size MMC. So that's why we are saying 8 mm dia, taking 8 mm dia. Okay. To design two regular feature of size that will assemble, the designer can use their MMCs. Now, this is the very important point. Okay. To design, if we are as a design engineer designing some part, Okay, let's say we are designing. I'm taking an example. Okay, so in the first example, it's saying for first requirement of the regular feature of size is it only applies to a regular feature of size. Okay, so regular feature of size, I have again and again I'm saying regular feature of the size. Regular feature of size is the size which can measure with the help of vernier caliper. Okay, now here we take one example. As a design engineer, if I'm a design engineer and this is the shaft. Okay, this shaft is having a dia of shaft is having dia of 10 plus minus 2. Okay, so the maximum material condition is dia 12 and the least material condition is dia 8. Okay, so if I need to assemble, this is the second part with hole. This shaft is going to be assembled in this hole. Okay, so this previous point is saying to design two regular feature of size that will assemble. The designer can use their MMCs. Okay, so let's say if I have taken dia same, if I first of all I'm taking the same dimensions, dia 10 plus minus 2. Okay, so for hole, what will be the MMC? Dia 8 mm will be the MMC and LMC will be the dia 12 mm. So it is saying that we can take MMC. So dia 8 mm of hole will never, this shaft of dia 12 mm will never enter into this hole. Because why it is not entering into the hole? Because the hole diameter is 8 mm and the shaft diameter is 12 mm. Okay, so to assemble these both the part, the shaft and the hole, what I have to do is I have to change the dimension. Okay, from 10 I will take 14 over here. Okay, so I will change the dimension. So if I need to, in all the cases, if I want to assemble the part with one another, okay, so what will be the maximum material condition now of the hole? Will be dia 12 mm and least material condition will be dia 16 mm. Okay, so when both the parts are manufactured at maximum material condition, shaft is also manufactured at maximum material condition and the hole is also manufactured at maximum material condition, still they are going to be assembled with one another. Okay, so the shaft which is manufactured at maximum material condition and the hole which is manufactured with the maximum material condition are going to be assembled with one another. Okay, so as a design engineer we have to take such tolerances that both as a design into the design that both the part at maximum material condition will assemble with one another. Okay, it is the this is the concept why we are learning all these things. Okay, so the first requirement is rule number one only applies to a regular feature of size. Second requirement, the actual local size of a regular feature of size at each cross section shall be within the specified size tolerance. Okay, it is saying that whatever the size tolerance, let's say dia from LMC, dia 8 mm to MMC, dia 12 mm, these all the sizes, all the cross section sizes be within this size. Okay, so at each cross section, it does not exceed the 8 mm and 12 mm. Okay, so it is within this size tolerance. Okay, always at each cross section, the size of the actual local size of a regular feature of size will be well within the specified size tolerance. This is the second requirement of the rule number one. Third requirement is when the actual local size of a regular feature of size departs from maximum material condition towards least material condition. Okay, whenever the maximum material condition is here is 12 mm and least material condition is over here is 8 mm. When the part is departing from 12 mm towards 8 mm, okay, maximum material condition towards least material condition, so it is allowed to have an equal amount of departure. Let's say this part is having actual local size of 10 mm. So the maximum departure it can have is of 2 mm. Okay, then only it should enter into the envelope. If it is having maximum departure, let's say it is having 3 mm and actual local size is having 10 mm, it will not enter into the envelope. Okay, so this does not obeys the rule one. Okay, let's say this 10 mm size is 9 mm. So the maximum departure what we can have over here is 3 mm. Okay, So if we have this departure of 3 mm and this actual local size is of 9 mm, then it can enter into the envelope. So it obeys the rule 1. Okay, obeys rule 1. Now, fourth requirement is here. There is no requirement for a perfect boundary at LMC. Okay, so whenever we are manufacturing the part with least material condition, let's say at each cross section, the actual local size is at of 8 mm, which is the least material condition, which is equal to LMC. Okay, so the maximum variation, maximum form variation up to the MMC. Okay, so the maximum variation we can have over here is 4 mm. Okay, so dia 8 can have maximum variation of dia 4 mm. Okay, so this is very, very important, that the maximum variation we can have is up to the maximum material condition, which is 12 mm. So this is the maximum variation we can have at least material condition. Okay. Fifth requirement is when the part is produced of a regular feature of size at maximum material condition, it should have the perfect form. That's why I have previously also told you that why it is called the perfect form at MMC. When the part is produced at 12 mm, each actual local size of this part everywhere it is 12 mm, then this part should have the perfect form. It shouldn't have any error in the form. Okay, if the part have perfect form, then only it will enter into the envelope. Okay, if the part is not having the perfect form, it should not have the enter into the envelope. Okay, so that's why if the part produced of regular feature of size at maximum material condition, which is dia 12, then it should have the perfect form or shape. Then only it will enter into the envelope. Okay. So this is the fifth requirement. Now, one thing I will also discuss with you, that why this rule is also called the individual feature of size rule. Okay. Individual feature of size rule is rule number 1 is also called the individual feature of size rule. Why? Why it is called individual feature of size rule is because it does not controls the location and the orientation of the feature of size. Okay, so in this is called individual feature of size because it does not control the location and orientation feature of size. Okay, so whenever it is manufactured at maximum material condition with the bow-like structure. Okay, so the axis of the part is not perpendicular to the face. So this rule number 1 is applied only to the diameter. Okay. So only to the diameter it is applied. That's why we are applying only to the regular feature of size. Okay. Not to the overall length of the part. Okay. So not to the overall length of the part. So the length of the part is independent of the diameter. Okay. So that's why with the rule 1 does not it is individual feature of size rule and does not controls the location and the orientation. With orientation, I am talking about the angular. Okay, it can be perpendicular or parallelism. It does not control that. Okay, so this is all about the rule number 1. So thank you everyone. In the next discussion of the rule number 1, we are going to discuss some how to override rule number 1 and all other things. Okay, so thank you everyone. See you in the next session.